Hello, and welcome to the City of Truth. Episode 6, The Existence of God, Part 2. Last week we covered our most fundamental argument for the existence of God. It was rooted in first principles, in the foundational beliefs of science. There are a number of other arguments for the existence of God. They have to be understood within their proper context, however. These are meant to supplement the argument of the previous episode, which isn't based on any particular observations, but rather on basic truths about how the world works. These following arguments are different from that one. One is probabilistic, the other is super weird, and in the next episode we'll cover two others that are about our basic perceptions in life. Perhaps they can be convincing on their own, but they do leave wiggle room. I don't think the argument from last week does leave wiggle room. First, we will cover an argument that's more of a curiosity than a proof. 6.1. Anselm's Ontological Argument. Anselm's ontological argument has got to be the craziest one, and the most widely misunderstood. I debated even covering it because I doubt it ever convinced anyone, really, except for maybe a few weird thinkers. It's bizarre. But if properly understood, it does actually frame the issue of the existence of God in an interesting way. For that reason, it's worth covering. St. Anselm's basic idea was this: God is the greatest conceivable being, that being of which nothing greater can be conceived. A maximally great being. But to be maximally great, this would entail having the greatest possible properties. Existing is greater than not existing. We hold to the idea of a maximally greatest being, and so it at least exists mentally. But that means it must also exist in reality. Therefore, God exists. Okay, let's break this thing down. It sounds ludicrous. It's not convincing on first glance. But there is a deep insight here. Think about it this way. There are three modes of existence that some conceivable object could have. The first would be those things that exist, like chairs or the sun. The second would be things that could exist. They're not mentally self-contradictory and can exist in the mind. And the last are things that can't exist as they are self-contradictory, like a square circle or a married bachelor. Three categories: exists, possible, impossible. Got it? Good. What Anselm is saying is that God, in virtue of his unique quality of being the optimal being, by definition, can't fit in all three categories. Because the very notion of God entails existence, that means that you can't say he could only possibly exist. Either he exists, or he is self-contradictory. God alone can't fit into the possible category. There's an easy answer to this by the atheists. They just say that God can't exist at all. And some argue that the concept of a maximally great being is self-contradictory. That means that God falls into the impossible category, and there's no dilemma. But the alternative is actually rather concerning for those in doubt, if you pay heed to the consequences of philosophical thought and take them seriously. If you don't think the notion of God is impossible, if you think he might exist, and that he isn't self-contradictory, then you are actually required to grant that he does exist. Because the category, possible but doesn't exist, is not an option for God. If he's not in the impossible category, then he's in the exists category. I think a certain type of mind may actually find this convincing. I find it weirdly compelling myself. If you can conceive of God, then that entails that he must exist. This has actually been written out in modal logic before, too. That means that certain philosophers have actually written this out as a sort of mathematical type proof, if you accept the premises. If you accept the definition of God as maximally great, and you grant that it's possible God exists, then it is a logical necessity that you grant that he does exist. Like I said, an atheist will simply argue that God isn't possible. It's interesting, nonetheless, and shows that same strange tendency in the world where the existence of God seems to be the preferred direction of things. The atheist case is a really tough sell. You have to prove that a concept that, by all accounts, seems perfectly coherent is actually self-contradictory. For the theist to win the day, you simply have to grant that the concept of God is at least not insanity, and the argument wins. Section 6.2. The Nested Probability Argument. My favorite version of a probabilistic argument for God is one I haven't really seen anywhere else. The argument from nested probabilities. I've seen the arguments separately all over the place, but I haven't seen anyone combine them together. That combination is important because it mitigates the most fundamental problem with arguments from probability. The way they are circumvented is simply to move up a level of analysis. The nested probability argument circumvents that. One of the assumptions about science is called the Copernican principle. It's the idea that we just aren't special. If there's something that makes us look like we're special, then we're probably screwing up somewhere. The main way that expresses itself today is in low probability situations. If you have a circumstance where it appears that there's a really, really low probability that things happen the way they did, then that seems special. It seems a violation of the rules for a consistent, indifferent, clockwork-type universe. If everywhere else processes can be explained consistently as inevitable, and regular, and natural, then the odd exception really stands out. Imagine you walk into a junkyard, and there are scraps of metal everywhere jumbled about. Then in the middle is a functioning laptop running a game. Probably Skyrim. That game was awesome. Would you conclude that some of the random junk just happened to be in that configuration? The probability is very low. Instead, you'd conclude something else plopped the laptop in there. It's inconsistent with junkyard rules for a laptop to be buzzing along. The origin of life is just such a situation. Life is stupidly, insanely complex. The things we've learned about the complexity of life over the last century are rivaled only by the things we've learned about the size of the universe over that same period. We just can't get our heads around how mind-bogglingly complex it is. It's a low probability event that such a thing would randomly form. That's understating it by quite a bit. Let's get into some details here. I'll avoid the technical terms about autocatalytic ribozymes and chirality and such. Many scientists think that life today originated from a molecule called RNA. RNA is useful because it's a single molecule that can both encode information and do things. With DNA, you need separate proteins to do the work. Now, RNA isn't stable outside of a narrowly defined environment. Let's skip that. We've never seen it randomly form in the natural environment. Let's skip that too. Once you have RNA, you need it not only to self-replicate, but grow and adapt and engage in processes that allow for the development of complex life, or evolution. Let's skip that too. Even the constituent elements of RNA don't appear to form together in large amounts on a regular basis, though they do sometimes form. Let's skip that too. Notice we're skipping a lot, but I'm getting somewhere with this. A self-replicating RNA molecule would consist of something like 110 base pairs. What does that mean? RNA is like DNA in that it encodes information by sequences of molecules. Those sequences will give the RNA a specific shape, which allows it to do work. If we have about 110 base pairs, we can make a bit of RNA that copies itself using the stuff in the environment. To be clear, this would absolutely not be sufficient to result in the formation of complex life on its own, but we're glossing over that. We're going as simple as possible. So we need 110 base pairs. But the environments where RNA could form also forms a bunch of other chemicals that aren't part of RNA. Perhaps under some conditions, one or two of these can be substituted for the ones already in RNA as we know it, but most of them can't. So for convenience's sake, let's say there are 10 possible molecules that can form in our soup. It's way higher than that, but we're being generous and we're allowing for substitution, perhaps in ways we don't yet know. So we need a 110 letter sequence to come together randomly in this environment. These molecules don't show any order preference, by the way. Their natural combinations are random. In fact, that's what makes them so good for storing information. You can easily arrange them in any sequence. We have an ideal environment where all of the constituent chemicals necessary for RNA are gathered together in a big slimy pool. There's energy to work with, and maybe even a hot vent on the sea floor. There aren't any other chemicals in there to mess things up. The constituent chemicals are being regularly replenished somehow. The RNA is stable somehow. And somehow these conditions will hold perpetually. What are the odds that our 110 letter sequence will form in this soup? It doesn't seem too crazy. It's only 110 letters. Well, if there are 10 molecules that we're allowing for as a possibility, then the odds of getting the first letter right in a random sequence is 1 in 10. Then after that, the next letter is also 1 in 10. So what are the odds of a specific 2-letter sequence forming? Well, 1/10 times 1/10, so 1 in 100. Basically, for every letter we add, we slap another 0 onto the odds. Again, to be clear, the odds are actually massively worse than what I'm explaining here, but we're being as generous as possible. So since we need 110 base pairs, the odds that our sequence would form is 1 in 10 to the 110th. So a 10 to the 110th power. That is a ridiculous number. It's hard to convey how ridiculous the number is because of scientific notation, but the number of humans on Earth is 10 to the 9. The odds that you'll win the lottery is 10 to the 10. The number of stars in the entire observable universe is 10 to the 26. The total number of bacteria on Earth is 10 to the 33. So what does this mean? If you gave every star in the universe its own primordial Earth, and you gave each of them the same number of humans as there are on Earth, and you gave each human a giant tub of this goo to attempt this combination, and you let them each try once a second for their entire lives, your odds of this forming once somewhere in this universe is still much worse than winning the lottery. For even more comparison, there are an estimated 10 to the 80 atoms in the universe. If every atom in the universe was an attempt to make this sequence, you're still 30 orders of magnitude short. And this is the most generous scenario we can create. It's absurdly generous, in fact. If anything, I'm being entirely too kind to the idea that this could happen. The odds are just that low. The real number is probably more like 1 in 10 to the 2000th once you factor in the other things we ignored. And keep in mind, this is not life. This is the simplest conceivable form of a replicating molecule we can think of. It can't move, can't intentionally reproduce, it isn't self-contained, it doesn't metabolize anything, it can't seek out new materials, none of that. It's just a molecule that copies itself. It's maybe 1% of the way to life. That's simply for a non-living RNA strand a little over 100 base pairs long. Actual ribosomal RNA has about 3,000 base pairs. The simplest life form we've ever seen had 180,000 base pairs. And even that's a parasite which can't live independently. For such an organism to spontaneously form under any conditions, the odds are so absurd that there aren't words for it. It's even worse for DNA or protein synthesis. This is just scratching the surface of how unbelievably unlikely it is that we would find life on Earth, if it formed by random processes. To get an idea of it, we still to this day can't build a machine that does this. We haven't built a machine that contains within itself all the information needed to build a new copy of itself, that can navigate the world and then process raw resources to make that copy. And if you found one, you bet it didn't spontaneously form in that junkyard. All well and good, you may say, but there's an easy way around this. Make a bigger universe, and all your problems disappear. In fact, if the universe is infinite, you'd expect this to happen an infinite number of times. And that is a perfectly reasonable argument. It does explain away the low odds. But now we have a new problem, and I don't just mean the potential irrationality of an infinite universe. The universe itself has conditions that are extremely low odds. It's called the fine-tuning problem, and it's a legitimate problem in cosmology. Basically, the initial conditions and physical constants all have very specific values that, if adjusted even the slightest bit, the universe couldn't provide for life. The low probability condition strikes again. And that's not even touching on the explanation of the origin of the universe. That is an unsolved problem. There is no known physical process by which matter and energy come into existence. You can swap one for the other, and generate matter-antimatter pairs, but that assumes the energy for creating matter already exists. You just kick the problem back one step. So many have speculated that the problem can be solved in the same manner. Perhaps there are many universes, a multiverse. String theory, for instance, seems to allow for 10 to the 500 different universes to form. Obviously, the only ones where we'd be making observations are the ones where life is possible. So it looks low odds to us, but it's an inevitability in a multiverse. Well, first, I think it's important to understand that at this point we've completely abandoned the realm of science. That's not to say science couldn't ever consider these questions. But these aren't really based on anything falsifiable, any direct observation of the theorized multiverse or anything like that. It's just speculation. And to be clear, speculation is okay. It's useful and valuable and interesting and can provide insight. We just have to make sure we're clear about what we're doing here. We are now speculating. So now we have our multiple universes, which explains away the low probability conditions, right? Not so fast, actually. A multiverse doesn't actually get rid of the low probability problem. Why not? Well, the universe is really big, and we're really small. Let's imagine a totally random possible universe arrangement. The larger and more complex it is, the less likely it is for it to show up. So the most likely observer is the one who is in the simplest environment for that observer to appear. That means, at best, perhaps a simple one-star solar system, and at worst, a brain in a jar, assuming that our conscious selves are just brains for the moment. Or one dude in a warm cardboard box, maybe. But that's not what we see. Instead, we see a big, incredible, complex universe that is at least 92 billion light-years across and contains hundreds of billions of galaxies. This is, once again, a very low probability event. It's much more likely in this scenario that you're a brain in a jar hallucinating your experiences than that this is actually happening. But that's also self-refuting because those supposed hallucinated observations are what led you to this conclusion in the first place. If you can't trust your observations, how can you trust the conclusions based on them that you're a brain in a jar? Does your head hurt yet? It probably should. You've been thinking a lot, and your jar can only handle so much. I'm kidding. The point is this. The random observer in a multiverse isn't like what we see, again, unless we're in a self-refuting state. So we are, yet again, in a low probability event. Even when we ventured into the realm of pure speculation, we couldn't escape the trap. So here is my claim. It does not appear that we can construct any scenario where we can escape the low probability situation. So the explanations offered don't actually help us solve the dilemma. Let's go back to our laptop in a junkyard example. It seems highly unlikely that it spontaneously formed there from the scrap materials. This is a low probability event. There are two ways you can explain this. The first is to just say that we are stupidly lucky. By some practical miracle, we just happened to get a laptop that spontaneously formed out of the junk that one time. Not very satisfying. And again, given that it's a low probability event, we should almost certainly prefer any other explanation to this. The second possibility is that there is some other factor which is not accounted for and which explains the situation. Like the junkyard owner forgot his laptop. We can't appear to find any sort of universal natural principle that can let us out of the low probability trap. So do we throw up our hands and proclaim ourselves stupidly lucky? Or do we instead conclude that there is another factor at work which is not a universal natural principle? Well, given our conclusion last episode from the premises of science, it seems pretty reasonable to conclude that that other factor is the one we've already discovered. This does indeed solve our low probability problem, and not in an ad hoc manner, but with some other object we have already concluded must exist. Now, is this a God of the gaps argument? Yeah, kinda. I'm generally not a fan of that sort of argument, as I expressed in a prior episode. And I don't think it should be the predominant reason anyone should argue for the existence of God. But what's the general issue with the God of the gaps argument? It's when you take something that conceivably could be addressed by a naturalistic argument and instead explain it away by just chalking it up to God. It's a way to flake out of the responsibility of seriously considering the issue by positing something new that magically explains away the difficulty. It's also intellectually dishonest, because you're taking a situation where there could conceivably be a naturalistic explanation, but for which we have near total ignorance, and then claiming that the only explanation is a divinity. If the above argument is taken in the wrong way, that looks to be exactly what I'm doing here. Really, it does. That's why I'm slapping on these caveats. This does not prove God. What it does do is show us two things. First of all, to answer these questions, by attempting to use the Copernican principle to get out of our dilemma, we actually walk straight out of science land and into speculation land. And in doing so, it didn't even help us. More than proving that this problem is solved by God, though to be clear, I think it is for other reasons, it shows us that we can't use the traditional methods of science to posit a naturalistic solution. We aren't just butting up against ignorance. We're butting up against the end of science, its inherent limitations. Science cannot provide us with an answer here. Instead, we stepped into the world of naturalism, of philosophy. The step was subtle. You probably missed it. It sounded like we were talking about science the whole time, didn't it? But when we went into the question of the multiverse stuff, we weren't dealing with data. We were proposing an explanation based on a set of ideological assumptions. We were using a mental model to propose an idea that could fit in that framework. But by using the assumptions of naturalism, we found that the solution often proposed actually creates the same dilemma we were trying to avoid. And an even greater one if you think about the brain in a jar thing. That doesn't mean that this is the only conceivable solution that naturalism could propose. But it seems pretty clear that everything we observe shows us living in low probability conditions. So let's grant that for a second. We have two models being proposed. Either there is a purely natural explanation for our existence, or there is a supernatural explanation. If we live in low probability conditions, on at least two levels, then which model better fits those facts? Well, having an explanation for the low probability is superior to not having one. So the supernatural explanation, in this specific case, provides better explanatory power. And this is further strengthened by the fact that in the last episode we concluded that such a supernatural explanation must exist already. It's not a slam dunk. A naturalist may be able to propose a theory that avoids the dilemma, but I haven't seen one. Frankly, I don't see how one is possible. We really are in a low probability state. So for the time being at least, it is evidence in favor of theism. Quote, "An honest man, armed with all the knowledge available to us now, could only state that in some sense the origin of life appears at the moment to be almost a miracle. So many are the conditions which would have had to have been satisfied to get it going." Dr. Francis Crick. Next week, we will address our last two arguments for the existence of God, and take a more practical approach to the question.